So now let me share the slides and where we will actually discuss about the missions. Okay, types of space mission. Okay, so in this space mission types, already some of them specifically mentioned, like the flyby, orbiter, lander, rover in your syllabus itself. I have also included some of them as well. Also, the human spaceflight or crewed missions are also included in your syllabus already. So you can see that some more things are also included for the completeness of the syllabus. Uh, okay, and anyway, that is also useful for you, even for the exam or maybe for your learning, the completeness of the learning. And here, when I am discussing here these things, and simply I will give you an example. So, orbiter means actually a satellite that orbits around a celestial body. That celestial body can be anything, like the it can be Earth, it can be Moon, it can be Mars, or any planet. It can be, it can even can be uh, a comet or a small body like the asteroid maybe. So whatever it is, a celestial body is orbited by something, then we can call it an orbiter. But in this certain case, in this classification, I am actually only saying about only the orbiter or flyby or impactor or what kind of mission. I am actually confining my discussion only to or except Earth. Okay, so when we talk about the orbiter of Earth, all the satellites are actually orbiter of Earth, but we are excluding that in this discussion because we are more interested in about the lunar missions or other planetary missions, etc. So that will be discussed more in detail, or that is specifically discussed here. Anyway, the working principle or the basic science are almost the same. But anyway, it is much more difficult to land or maybe to orbit or have a rover or have a flyby mission, whatever, to another moon or maybe to this planet. It's much more difficult than having for Earth, that you know. Okay. So let's go one by one. So these are all the classifications that I had. Actually, there are much more classifications. So I have given a link here. Just a second. I will show you that. This is this is an interesting. So while preparing these slides and all, I came across this one. So I think almost all the countries listed here, but I couldn't find any Chinese satellites in this NASA. But anyway, in India, Russia, and ESA, all satellites are here. Here you can actually see many types of things are there. So, for example, atmospheric probe, balloons, maybe experiments, Earth observation. So it includes all kind of space mission, including Earth. Okay, weather satellites, sounding rockets. Those things actually I have avoided here because for the because we cannot have all this classification to be discussed. So these are some examples. So for example, if you want to see the flyby mission, you can take the flyby mission, and you can also see whether it is active or future or past, and what is the mission target, whether it is to Jupiter. For example, I want to see which are the Jupiter flybys. So you can see Voyager is there, Juice is there, Pioneer is there. So this is the way I can actually get a. So I cannot add all this to this slide anyway. But anyway, to have, if you want to know about any of this, you can actually click on them and read more. Okay, so I have given this slide. I will be giving this site link in the slide so that you can read on each actually. So there are many kind of, so you can go what is Pioneer 10 originally designed for 21 mission. Okay, so you can see the details. Okay, so also it is interested in that they are listed something like first place the trajectory to escape solar system into interstellar space. So like that, there are many things you can read. Okay, so just leave, and so I have given this link will be here, so you can use this link to read more about that. So nasa.gov/missions. That's all. So let's go to each of them. So I have taken only this much here. Okay, and in your syllabus, I think all of them are not there in your syllabus, but anyway, these are all the things that we have. Flyby, orbiter, impactor, lander, rover, sample return, helicopter or rotorcraft, then human space flight. These are all the different space missions types of space mission chosen for this topic or this class. That's all. I am not saying that these are the only thing that we have. Especially when you consider about the lunar or other planetary exploration, this is almost okay. Almost complete list. I am not saying that it is complete list, but anyway, important things are here. Now let's see one by one what is a flyby spacecraft. So flyby spacecraft actually used for two purposes. Okay, it is actually a two-in-one spacecraft in a way we can call it as. Sometimes it is two-in-one, sometimes it is actually just for the purpose of the flyby. So in the second slide, you can see that, so assume that this is the planet, this orange one, like looks like Mars or something. So anyway, you can see that it is actually coming near and going away. Okay, it is coming near and going away. That's all. It is not actually going anyway around it. Maybe sometimes it can even take orbits like say it can even come and go like this. That curvature may change, but anyway, this is the idea. But anyway, it is not going to orbit. Okay, because its speed is such that it cannot be, that planet cannot capture the spacecraft. So when we learn about orbiter, we will learn that usually we slow down the spacecraft so that the planet's gravity can actually capture it. Capture in the sense it is not falling into the surface. It is actually captured in that particular velocity and it will start to orbit around that. So whenever that is at that particular speed, that means it should be less than the escape velocity at that point, at that or that particular place. Then it will be captured by the planet. If it is more than that, that will be a flyby mission. Okay, so if it is more than the escape velocity, it can escape like this, and if it is less than the escape velocity, it can actually be captured. But the problem is that when usually a mission comes, or we have a mission and it is moving like this, and one more interesting thing is here. So yeah, we have some space. So for example, so this is the solar system, this is the sun. Anyway, it is not to scale. Okay, and assume that this is the earth. Okay, okay, and assume that the Mars is somewhere here. Okay, so Mars is also orbiting. Okay, this is the orbit of Mars. Okay, and the Mars is here. So when it starts from here, it initially starts in the gravity, or it is in the gravitational field of Earth. Okay, I'm not saying that the gravity is not everywhere, it is there. Even the sun's gravity is also there in Earth. Gravity is actually an infinite force. It will be everywhere. Okay, so we cannot say that sun's gravity ends here or Earth's gravity ends at moon. Even Mars will experience Earth's gravity, but it is tiny. That's all. But anyway, who is predominant? That is important. Okay, so when a satellite is being launched from Earth, it may go some earthbound maneuvers. Earthbound means it will go around Earth something in some elliptical orbit, and during that it is actually in the gravitational attraction or of Earth, or it is bound to Earth. Okay, then we can increase its velocity. So instead of having that initial velocity, that 11.2 meter per second yesterday, kilometer per second that we discussed yesterday, that speed is from the surface of Earth. So it is impossible to achieve that velocity suddenly from the surface of Earth. So instead of that, we go to space and we gradually increase that speed, so that when you go to some height, this value changes. That I showed you that equation yesterday. So when you are at a height, the escape velocity will be smaller, and so that at this point escape velocity will be smaller, so I can burn my engine and it can escape Earth's gravity. So it is escaping Earth's gravity. Doesn't mean that at this point there is no gravity from Earth. Actually, Earth's gravity is there, but at that point the most strong gravity that is experienced by that spacecraft is actually from Sun. So at this point, when it comes something like this, okay, assume, okay, something like this, at this point it is actually orbiting around Sun. Okay, so initially it was orbiting around Earth, then later it is orbiting around actually around Sun, or we call this part. Okay, so now this is earthbound, and in between the planet and this is called a heliocentric orbit. Because even though we do not feel that it is orbiting around the sun, but actually it is in the attraction of sun. That is why it is called a heliocentric orbit, and it goes through that heliocentric orbit, and it actually comes to this planet Mars, or whatever planet it is intended to be, and it will be at a high velocity. Usually it will miss the planet, and it will go close by and may go something like that. So because of its gravity, its path may change, but anyway, it cannot be captured if it is at a higher velocity. Okay, so that is the case for a flyby mission where the escape velocity is more than the planet's escape velocity. The satellites or the spacecraft's velocity is more than the escape velocity. It will escape, and those kind of missions are called the flyby missions. So then, what is the purpose of having a flyby mission? So one important thing is that, so anyway, you know that we are achieving every achievement in science, or maybe in rocketry as well. It is step by step. We didn't go directly to moon actually. So we started something like maybe having small sounding rockets, then bigger rockets that can go to space, then that can able to orbit Earth. Then we took man to space. Then we sent probe to some small probes to there. Then we tried with animals, something like that. So it is step by step. So it is better to have simple and easy and effective way of getting data from the, or having the data from those planets. So that is why flyby missions are it's an easy kind of space mission when compared with the lander or rover or maybe orbiter even. Okay, so now that is one purpose. So when it comes nearby, it can actually have some photo and information can be collected. So we will discuss about more about that. And the second thing and most important thing is actually it can be used as gravity assist. Okay, so nowadays, especially the Voyager or Pioneer missions, they were actually did something like they actually used this gravity of giant planets like the Jupiter and Saturn to improve its speed actually, or to get energy from those gravitational energy from that planet, and that part of it, very a part means it's a tiny part, can be transferred to the satellite. So just compare the size of the a spacecraft with the size of Jupiter. Okay, it's even not comparable. So it get additional gravitational energy, so that that energy will be transferred to its speed, and so that it get additional boost, something like a slingshot from the planet. So that is another purpose. But at the same time, during that gravity assist, we can also take the pictures of that planet they are close by. But that is the case of Voyager and all, or many missions actually did like that. But there are specific mission for flyby itself as, especially for moon and all, we had missions like that. Flyby were there. Okay, so now we can, let's see so how this happens. Okay, so this is how this is happening, and now we can see there are different phases for this. Okay, some of the phases is something like the observatory phase, that is the first one called OB. This begins when the target can be better resolved in the spacecraft's optical instrument. So optical instrument means it can be anything, any type of camera, than it can from the Earth-based instrument. So observatory phase. So if it is not close by and the images are not that good as, even good as the Earth-based telescope, then there is no point in that actually. So, but when it goes closer and closer in at a particular position, or after a certain distance, we can actually see those planet, or maybe that planet, much better than that of what we can observe from Earth. So that is called the observatory phase, because from that moment onwards, we actually starts to uh, properly observe the planet, or that is where the observation, proper scientific observation starts. Okay, then it actually some few months before the flyby, so we can call it as a flyby. Then the flyby phase is actually classified into two, that is, one is called the encounter phase, sorry, far encounter phase, and another one is called the near encounter phase. Okay, so far encounter and near encounter, so it's a kind of a definition anyway. So it is far encounter is defined as something like when we can no longer see the full disk of the planet. The idea is that when you go closer and closer to any object, some with a camera, just imagine. So once you are so close by, you cannot actually see that entire thing in the camera. We will see only a part of that. So something like that. Okay. So in that moment, when you cannot no longer see the full disk of the planet, we call it as the far encounter. And when it reaches its closest possible distance, and that is called the near encounter. And during all this time, the camera and other instrument will be active, measuring maybe the ring systems. Okay, so ring systems, magnetic field, then the if there is some camera, it can actually different kinds of camera will be there, and radars will be there. So all those things will collect data started to collect data from the planet actually. And the problem is that since it is not orbiting, it cannot cover the planet completely. So whatever it comes to the vicinity at that moment, that will be captured. That's all. Okay. So that's the maximum possible thing. So this is, I think, the picture of Ganymede taken by the Voyager 2, and you can see that it's not an orbiter. It went nearby that during a flyby near Jupiter. So at that time, it got whatever it is possible to capture, it captured. Okay, so that it couldn't complete it. But even though it couldn't complete, even this close by pictures, because that is the first time we are getting those kind of pictures from the planets, or maybe from the moon, other moons actually. So they gave us a lot of information, and some, what to say, this, yeah, it is something kind of a groundbreaking discoveries, or maybe some new visions, or completely the vision about the planets and all the things actually changed. Our precursor knowledge actually changed by this spacecraft actually, especially Voyager. So this is a photo of Voyager and stitched down something like this. Okay, so that is flyby, and some examples of flyby are Luna 1. Okay, it is also known as Mechta, or it's in Russian. That is, the meaning is actually dream. Okay, so that is the first lunar flyby. So it is the first spacecraft to fly by other than Earth. Okay, and it is to first to orbit the lunar flyby, and it is the first spacecraft to reach the vicinity of Earth's moon, first spacecraft to leave Earth's orbit, first spacecraft to be placed in a heliocentric orbit. This is what I said as the heliocentric orbit. Okay, so it is, you can imagine it is something like this is Earth, this is moon. Okay, anyway, it is not again to scale, and this is Earth orbit, and the sun is here. Okay, so it went something like, maybe I don't know exactly the trajectory, but anyway, my concept is so it went something like this. Okay, so it actually doesn't get captured, so that it will be in a heliocentric orbit. Okay, it should be orbiting around the sun unless it is uh, hit to some other planet or some other object. It will be keep on revolving around the sun. Okay, but we don't know, since we lost the contact with that. That's how it works. Okay, the second one is Mariner 2. That is the first robotic space probe to report successfully from a another planet. Okay, so something like it's a Venus probe, and it is the first robotic space probe to uh, fly by around a planet, not a moon. Okay, it's a planet. It is in 1962 by NASA again. It's not again. Anyway, first Luna was by Soviet space program. That's by Russia. Okay, USSR basically. At that time, it is not the usual Russia. That is actually USSR. Now, this is the best example for a flyby spacecraft, and this one of the most important space mission in the history of space exploration. That is called the Voyager program. That consists of two probes called Voyager 1 and Voyager 2. They were launched in 1977 to take advantage of a favorable planetary alignment. And they launched in 1977 to have a favorable planetary alignment, because to explore the gas giants and to have a gravitational slingshot, because to get more energy from them, because this Voyager as the name suggests, it's a voyager. It's voyaging, not to a specific planet or specific target. Usually, the space missions are like that, but it is actually went on to the interstellar space, or it is planned to go to the ever-ending space, something like even beyond the solar system. It's already beyond the heliosphere, and it is in the interstellar space right now. We can say that it is not in the solar system right now. It's beyond the solar system. This is the man-made object, that is the farthest man-made object, and think that it's and know that it's still sending data back to Earth. Okay. Now the Voyager 1, this is the list of flybys it made during its voyage, something like the Jupiter. Voyager 1 had two, something like Jupiter and Saturn, and discovered the volcanic activity on Io. So this is the first time. Detailed imaging of the Great Red Spot. Then studied the Titan's thick atmosphere, detailed the ring structure. Then Voyager, you can see Voyager 2, Jupiter, observed Ganymede and Europa. Then explored Saturn moons and rings. Then only spacecraft to visit Uranus, discovered 10 new moons and its tilted magnetic field. Only close-up views of Neptune, discovered great dark spot, Triton's glacier, and many things actually it were able to discover. That is a Voyager 1 and 2. So the perfect example, if you want to say for a flyby mission, this is the best one. Okay. Now, the second thing is the orbiter spacecraft. Okay, so in the case of an orbiter spacecraft, as the name suggests, it makes orbits around the that particular planet or whatever. Okay, it may be whatever celestial object. Just a second. Okay, so that is about the orbiter. So in the case of orbiter, actually when it comes like this, okay, it is something like the flyby. Usually in the case of a flyby, the trajectory is almost same in the sense that after this, it will go like this. Okay. In the case of an orbiter spacecraft, the orbiter will be slowed down, okay, using some kind of deceleration technique. So it will be decelerated. Okay. So it will be decelerated for orbit insertion. That name of getting into the orbit is called the orbit insertion. So this term is also used for any orbit. It's for orbit insertion for any satellite, that is for Earth also. You will hear this name, that orbit insertion. Why? Because for every orbit, what is crucial is that they have to be in that proper velocity. Once you get that proper velocity, it can stay in that orbit. That's it. So that is how they achieve the orbits. They actually make it into that particular velocity, then it will stay in that. If the velocity is more, it will go to a higher orbit. If the velocity is less, it will come to a lesser orbit. So it is how it is happening. So that is the orbit insertion at the correct moment. So it has to be decelerated. And for deceleration, they use a technique called reverse firing. So usually when the spacecraft, if you assume that this is my spacecraft, okay, with some solar panel and all, okay. So assume this is my, okay, and it will have, so anyway, whenever it is going, every spacecraft, even the satellite, actually consists of something called a thruster. Thruster are mini rockets actually. It can actually burn fuel, usually some liquid fuel, so that it whenever it needed, it can stop and all. So liquid fuel will be there. It can be burned whenever it is needed. So when it burn, it will move in this direction. Okay. Suppose here you can see this is coming in this direction, and if the rocket get fired, its speed will increase. So that the problem is that it won't be ever get captured by the planet. So what they do is that they reverse the direction, reverse the orientation of the spacecraft so that its nozzle is facing in this direction. Now it get fired. If we fire that rocket, it will effectively reduce the speed. Okay. This is called the reverse firing technique. So when it reverse fired, its speed will decrease so that its speed becomes less than that of the speed of the escape velocity. Okay, it becomes less than that of the escape velocity, and then they can actually get. Then there is nothing. The planet will automatically capture the satellite, and it will start to orbit around that. Okay. Okay, so that is about the orbiter spacecraft. Okay, so it has many. It keeps on orbiting like the satellite, so that it can actually cover the entire surface. Almost it can be covered, uh, because when it orbits, also there is self rotation, so that during that entire orbit, it can actually map the entire surface of the celestial body, and maybe sometimes it can go to the farther part, like the maybe it. So for example, so if this is the planet, and if the earth is here, when the when this what is called the orbiter comes here, the problem is that it cannot send data, so that data will be stored and then it will send. So some kind of a blackout will be there. So this is one kind of a blackout. So this usually, when you read about these missions, or when you closely watch the live telecast and all, we will see that there will be a blackout time that usually happens when it is behind the planet, actually, when you are from the point of view of a person from a. Okay. So then this is another example just showing that figure. Okay, so this is an orbit. Now, orbital spacecraft, one or two examples, that's all. Maybe the first artificial satellite to orbit the moon, and that is the Soviet space program in 1966, March 31. See the date, okay? Then the second one you can see NASA, that is Lunar Orbiter 1, 1966, August 10. So both are in the same year. Why that is more important here? Because you can see this is just some 4 months apart. So this is a time when the space race is actually going on. So they are actually having a friendly war between USSR and USA. So that who is first, who is first, who is first. And you can see that Luna 10 happened, the first satellite to orbit moon, that is in 1966, just 4 months after. Then the first American satellite to orbit the moon is Lunar Orbiter 1. So we will tomorrow, hopefully, we will discuss about uh, that Cold War and Space War, because that's so important in the history of space exploration. Okay, now another two example. One is Mariner 9, that is another orbiter spacecraft. Then Cassini-Huygens, that is actually another spacecraft which is orbited actually. This is actually an interesting mission. The second one, this is okay. The Mariner one, you know that it is the first spacecraft to orbit another planet. Okay, another not another celestial body. Okay, that is actually anyway Luna. But here you can see this is the one to orbit another planet. Okay, it's not the moon. Okay, here Cassini-Huygens is an interesting mission in the sense that actually Cassini has another probe called Huygens. So this Huygens was able to probe Titan, that is one of the moons of Saturn, and it unveiled that there is lakes of methane is there. So initially they were planned at the end of the mission. The Cassini spacecraft itself were planned to crash land to the surface of Titan, so that during that crash land itself they can get many data. So it was planned, but once they detected, the Huygens probe actually detected this lakes of methane. They thought that there might be, so methane is maybe sometimes some methane based life forms may be there, especially some sea is there, maybe underwater life may be there. So it is, we don't know whether something is there. So just imagine that some other alien actually sending some spacecraft to study us, and that is collapsing to the our Earth's atmosphere and to a place, maybe at our place. Just imagine. So it's not ethical. So they decided to change the trajectory of Cassini, and actually it impacted or plunged into Saturn's atmosphere actually. So instead of going to Titan, where we are expecting some life maybe, so it is better to have where we are not expecting any life, that is Saturn's atmosphere. So that is how it happened. That is a story of Huygens actually. The another one is impactor, another type of what is called the kind of a mission is actually impactor. So in the case of impactor, it is something like a suicidal mission. Okay. So it can happen in two ways. Either the entire spacecraft itself can go and collapse into the crash land into the surface, like the high jumps happened with the Saturn. It can go and crash land. It is not a safe landing or a soft landing. It will be crash landed. Why we are doing that? Because it is much more easier than having a soft landing. So initially we do what we do. We can have something like that. So that is one thing that they do. Either the satellite itself or maybe there will be a specific impactor. So one example is that in the case of Chandrayaan 1 mission by ISRO, the Earth is sorry, the Moon is here, and that orbiter Chandrayaan actually one actually orbiting around that. And during that orbit, it actually ejected or tried to land a probe called the Moon Impact Probe. That is actually an impact probe, and that impact probe went on and hit the surface of Moon. So now what is the purpose of this impactor? So anyway, when it land, we can even call it land, when it crash land, when it crash land, what will happen? It will anyway, it will deteriorate. Okay, it get damaged. It won't work anymore. But during the descent towards the surface of that celestial body, it can actually get a lot more data about that. Okay, so it can actually get analyze the atmospheric structure and also how the gravity varies as you go down. That thing can be because that is crucial for landing another lander later. So that is also it can get an idea about the near surface materials. So, but the problem is that once it is landed, it is gone. Okay, so it will send data till it crash on the surface. And one more advantage is there, that is when it impact or hits, it will actually uh, eject some material from the surface. Actually, it is something like throwing something on some sand or something. Some material will shatter away, or some kind of some material will eject from the surface, and those ejecta can be studied more, especially in the case of Moon impact probe. If you remember the detection of water on the Moon that happened with the Chandrayaan 1, and it had another mm, scientific instrument called Moon Mineralogy Mapper, or MQ by NASA. Actually, Moon Mineralogy Mapper were able to find the existence of water there. Also, this Moon Impact probe, when it hit and it sent back data, it was actually that from that ejecta, we were able to find the presence of water in it. So in the close by surface, there were water content. So in two way, it actually confirmed the presence of water on. Okay, so that is about the impactor probe. So anyway, it is a suicidal mission regarding the impactor, but anyway, it is useful. Okay, so it's no recovery. Okay, it's a one-time use thing. Now, impactor example is the Luna 2, that is something like the first human-made object to impact on the Moon. Then deep impact is there. That is actually another interesting thing. It is not impact on a big object. It is actually impacted on a projectile impactor on the Temple 1. Okay, that is a comet on the Temple 1 comet, and analyzed the what is coming outside. The released material was analyzed by the flyby spacecraft. Okay, so that is about the Temple 1. Okay. Okay, then lander. So the lander is there, which is actually which is able to land to the surface. Land in the sense, impactor is actually we won't call them as a lander because it is not landing properly, or it is actually crash landing. But in the case of others, the lander means it lands softly. When only it's lands softly, then we can call it as a lander, because once it is landed, okay, the all the instruments should work. That is a condition. It can be any kind of landing can happen, or there are several methods for landing, but whatever it is, it should land softly. Okay, So that those instruments should work. Okay, that is the meaning of soft landing. So once it is landed, and if it is not working, then we can call it as a crash landing. Okay, so if from that impact something happens for that. Okay, so it is something like that. That is a lander. Okay, so lander has advantage is that it is actually it's sitting on the surface itself. So once we are on the orbit, we are actually watching the surface from a distant view. We are only getting an aerial view or a distant view. But in the case of a lander, we are actually touching on the surface so that we can get the real surface composition, structure, weather, geology, direct photographs, etc. So uh, that is something other than man, somebody, some robotic arm or a robotic mission is actually landing there. So that is about the lander. And there are many methods or mechanisms used to land a spacecraft. One is actually parachute plus airbag. Okay, so this is actually used in Mars Pathfinder and Spirit, Opportunity, etc., and which is specifically designed for by for this missions. So it is something like the initially they will slow down by using a parachute. Then again they will slow down. Sometimes they will also use some retro rockets as well to slow down. Then once it reaches near the surface just before landing, even with a parachute we cannot slow down. The problem is that especially in the case of Mars and all, the atmosphere is so thin. In the case of Moon we cannot even use a parachute because the atmosphere is that thin. Okay, but in the case of Mars, the atmosphere is not that uh, feeble as that of Moon, so that actually the parachute can deploy and it can actually slow down the spacecraft to an extent. But after it reaches near the surface, there will be an airbag system, something like the car's airbag. It will be deployed automatically. It completely covers the spacecraft, or it's around the spacecraft. Then it will land and it makes some bounce and all. Then anyway, it will safely land. Okay. So this all the shock absorbing will happen by these balloons around that or those airbags. Another one is a sky crane that happened for the Curiosity and Perseverance, a rocket powered descent. So here there will be a descent using the rockets, but once it comes near to that, that specific landing of the spacecraft will be happened by using some wires, actually some kind of a crane. It's called the sky crane. Okay, I'll show you one or two videos of that. Then power descent or retro rockets. This is the one that we use for Moon mostly, because this is also another important technology that is fires the. So when it comes down, there will be reverse rockets that will be fired and slow down the spacecraft so that it can touch down and in a well balanced way. Okay, so I think yeah, see this video. So this is about the Perseverance. I will just move a bit. Yeah. So those are our rockets actually correcting the direction and orientation. Okay, you can see those rockets. So this is the parachute. Now this is about the Perseverance. It uses the sky crane. Anyway, even in the case of sky crane, they are actually using the this parachute as well. But parachute has a problem that we cannot actually properly control where to land. Okay, that is the problem of the uh, uh, okay, so that is another problem. That is, if you use the parachute and balloon technology or the airbag technology, the problem is that we cannot precisely manage where to land. So that is where the sky crane is used. So even though the parachute will take you to a roughly to a place, but the sky crane, that is, you can see this is the system, that this system can go to anywhere it is needed. So this is how it is slowing down. But once it reaches near where it needed to be landed, you can see some technique. So some wires will come. Yeah, this is how it's getting landed. See, yeah. Once it is landed, yeah, it's gone. It will go and crash that somewhere far away. That's all. Okay, so this is how that is happening. The technology of sky crane is this. Okay, now let me go to next. Okay, so next slide, you can see the Spirit landed. Okay, this is the landing that is using the balloon technology. Let's go a bit faster. So here also you can see that they are using that parachute. Then also they will use something like, yeah, this is that technology. See, so this is again they are actually using that retro rockets. Okay, that reverse rockets. So now it will bounce again and again. It will bounce more than that of Earth because the gravity is less. But anyway, impact will also not that hard because of less gravity. Okay, now it will get opened. That will be deflated and it will open. So this Pathfinder is actually shown in the movie Martian actually. So there is a shot he walks near that. Okay. So this is about the that balloon and sorry, what is parachute and airbag technology. Okay, there are another legged descent with a proper shock absorbing. So it is not that easy. So using proper shock absorbing legs, actually we can land. Actually, it is practiced and actually successful. I'm not saying that it is impossible, but it is much more. It need to be not ideal for uneven terrain unless it is equipped with hazard detection, etc. So mm, it is bit more not much used. The mostly used one is actually that reverse firing technique. Then there is one more thing that is called the touch and go. So it is something like it will come near the surface and collect the data and go back. Okay, come and descend. Okay, or descend and then ascend. It just touch and go. Okay, so that is another touch and go maneuver is there. But anyway, we cannot call it properly as a lander. Just touch and go. That's all. So lander example, Luna 9 is there, the Soviet space program. Luna 9 is the first successful soft landing on the moon. And this picture is the first photo ever taken from the surface of another celestial body. You can see the that texture actually. And the InSight is another one, Mars to study the interior using a seismometer and heat probe, etc. And this happened in 2018. So this is another example. Now, another thing, the rover or the car, the robotic cars uh, that can run through the surface. Okay, so anyway, anyway, it's need that lander technology. Then only we can have the rover. Usually, that a rover usually go inside the lander, and once the lander is landed, there will be some way to descend this rover to the surface, and it can actually move with the wheels. It can actually move wherever it need and equipped with the camera, spectrometer, drills, robotic arms, and maybe sometimes even in the case of Perseverance and all, there is labs even. So the collected material can be tested in the lab. Okay, so it is the rover missions. Now rover example is Sojourner, that is the Pathfinder, part of the Pathfinder mission. So the mission name is Pathfinder and Sojourner is the name of this vehicle actually. Then this one is a Rurong, maybe something like that. I don't know how to read. It's Chinese. It is actually China's first rover working rover on Mars, and yeah, it is in 2020 and by CNSA, which is the Chinese Space Agency. Now, rover example, the best, one of the best example, it's there. That is a Perseverance. In short, usually we call it as Percy. And it consists of many interesting things like the drills is there. It can capture, it can collect the material, and it will be sealed in tubes for future sample return missions. And also it carried the Ingenuity helicopter, which is the one and only rotorcraft or the helicopter that happened in a celestial object. Okay, anyway, it cannot be happened on the on moon. A helicopter cannot have on the moon because of the thin atmosphere, but it happened in the and the photo that you are seeing is the selfie taken by the rover. Okay, then helicopter or rotorcraft, you can see that is the only one. It's Ingenuity, and it can hover, ascend, descend, and fly horizontally, reaching places inaccessible to landers or rovers. So problem is that for rover, it cannot actually, because it is moving through the terrain. So sometimes maybe some depending on the terrain, if it is uneven, it's quite difficult to move. Anyway, it can withstand to some extent, but not much. Okay. So that is called the rotorcraft or spacecraft, and the first one to go is actually Ingenuity, and it completed 50 flights. It was intended to some less than 10 number flight, just 7 or 8 flights it was intended to, but it flight 50 times actually. And it acts as a scout for the Perseverance rover as well. Okay, so before going to a certain place, Ingenuity will go and see how the terrain, whether it is good, how it's enough plain, or are there any gutter or some kind of a big stone, or so it will be scouted by Ingenuity, and then Perseverance can go. So this is the video of it's a real footage. So whatever you have seen in the past two videos were actually animations, even though it won't look like that. But this one is actually the real footage of Ingenuity flying on the surface. And the real challenge of having a something like this, a rotorcraft on another planet, is that especially on the surface of Mars, Mars has less atmosphere, thick atmosphere than ours. So it is difficult to fly there. So for flying, we need air. And the problem is that here its rotary blade should be so fast enough, and that system, that entire aircraft, maybe we can call it as an aircraft because it works in air, Martian air. Okay. So it should be so light as well, light and powerful rotary blades and rotary system should be there. Okay, so that is about the Ingenuity. Okay, well, what are the interesting suggestions in it? Okay, then the next one is the sample return. So sample return usually happens in manned missions as well, but I am not here mentioning about the manned mission sample return. Anyway, since people can go, then they can actually take material from there and come back. Not at all an issue. But here the sample return missions are the spacecraft which can actually uh, take samples from the surface. That is not a manned one. It is actually some robotic arm can take materials. Maybe they will drill, scoop with the lander and all. Then that lander will come back to the orbiter, and it will be returned back to the surface of Earth. So it is something like, the only difference is that with the crewed mission is that the main difference is that it is not crewed. Anyway, it is going and coming back. Usually all the space mission, whatever we mentioned till now, it is not coming back at all, but this will come back. So for that, it uh, need that kind of uh, design, something like it should come and come back and descend to Earth's surface as well. Okay. So So Luna 16 is an example. Then Osiris Rex. This is actually an interesting. It collected samples from asteroid Bennu and returned to Earth. Actually, okay. Okay, now let's go and see the next one is the human space flight or the crewed missions. Okay, So crewed missions, usually the term is used to not just for any spacecraft where a person is there, okay, human being is there. So even the mission to ISS, maybe just to the space or space shuttle, they're all crewed missions. And only the one and only space mission we had to another, or crossing the Earth's gravity and going to another celestial object, is the only one is that actually, that is the Apollo missions, and we went to the moon. Okay, other than that, there is no other space missions, but all other crewed missions are actually earthbound orbits. Okay, and important things are something like it too risky. Okay, so in the case of a robotic thing or anything, we can actually risk it. Something like whatever happens, it's not an issue, because there is no human being. Anyway, it is a loss of some money and all, but anyway, no life at all. But in the case of human space flight, actually, it's so risky to take them. So that is why it is so difficult to achieve that, or many space agencies are still uh, finding ways to do that slowly. Okay, so that is why it happens at the end as well. So beginning we will do with the simple missions like the flyby, orbiter, etc. But then finally, because to have human on space, the problem is with the everything. It is completely terrible and hostile environment. Like there is no oxygen, no water, no food. So we have to take water, take oxygen, take food. Then waste management should be considered. Then the pressure, it should be properly pressurized inside. Then temperature should be maintained. So all these things, for all these things, actually we need, and safety measurements are much more higher when concerned with the uh, humans. Something like the escape system should be there, some emergency re-entry should be there, and re-entry is so important because it's a human, so we have to get them back. Anyway, we cannot send them forever. Okay, maybe you will see some movies in which people are going by some cryo techniques and all. That is anyway in movies, but here we are actually responsible that we have to take them back. Okay. So two simple examples, but most important examples. One is the first human space flight, or man went to space. That is the Yuri Gagarin, the first man to space. And the second one is we went to another celestial object. That is actually the moon landing of Apollo 11. So okay, so that is the crude examples. Now these are the brief first missions. Okay, so first mission to moon by spacecraft type, flyby, orbiter, impact probe, lander, rover, helicopter. Not none yet because it's impossible. That's why. Then sample return, crewed mission. These are all the first ones. Okay, and you can see here an interesting thing. So. Till Apollo 11, all the lunar mission, USSR is the first to get, okay, all of them, and NASA to be the, or USA to be the second. But in the case of Apollo 11, they actually were able to. So that much pressure they had actually, because of all this first they USSR got. But finally, in the case of landing man on moon, NASA got it. Okay, did that first. And these are all the other planet. So this is for moon only, this is for other planet alone, first missions. Okay, it doesn't mean that here you can see that Mariner as the flyby mission, first flyby mission. It doesn't mean that it is the very first flyby mission. It is the first flyby mission to another planet. Okay, then Mariner 9, impact probe, then lander, rover, sample return. Anyway, crewed mission, there is nothing yet, but hopefully within some, maybe some 10 to 20 years, may not be needed. Okay, when you people get some, maybe get to some colleges or higher studies, you may able to fill this last line actually. So that is about the crewed missions. Okay,